Awesome. All right, we are getting ready to hop into our next reading / science time. This is the last of the simple machines that we are going to focus on before we start getting into some investigations of how these work, okay? So we're going to take a look at them in our world to get some background knowledge, and then you will know all about all 6 simple machines after today, so we can start putting them to work for us, okay? Very exciting stuff. All right, you have an activity that is structured very similarly to how your assignments were last week on Wednesday and Friday. This time we're going to be focusing on pulleys and wheel and axle. Pulley is a simple machine, and then a wheel and axle work together as one simple machine. That's what we're going to take a look at today, okay? Like we have, we're going to add a response and then read about pulleys and wheels and axles together. Go ahead, please, and click on that add response. While you are loading your response, I'm going to go ahead and read our main goal. Our goal today is to identify types of simple machines and their uses. We will investigate and build simple machines to understand how they are used. Right now, we're in that investigate portion, and you guys will be getting to the build portion very quickly. In order to do this, we are going to be asking and answering questions about a text, referring explicitly to the text as a basis for our answers, okay? But remember, this is just how you're doing it. This right here is your main goal. All righty. On slide 2, you will see the article, the anchor article that we have been using. I want you to go ahead and click on that. We're going to focus on pulleys and wheels and axles. Click on that, let it load up. I will also push it out to you on Dino so that it will pop up for you. There we go. Okay. Pulleys and wheels and axles. We have read about a ramp. We have read about a wedge. We have read about a screw. We have read about a lever. We are now right here on the wheel deal. So hop to that page where it says the wheel deal. And I'm going to zoom in a bit so that we can see it a little bit more easily. And then I'll have to scroll up. So I'm at the bottom of page 2. I'm looking at your screens, waiting for you to get there with me. So Tim, go ahead and pause on your video making right now. You're supposed to be on the article that we are on together. Awesome. Okay. The wheel deal. Please listen and think about how we use wheels and axles. The wheel deal. The wheel and axle is one of the oldest simple machines around. In fact, a wheel was found dating back 5,500 years. A true simple wheel and axle machine consists of a rod, which is called an axle, secured to a wheel. Take a look at this fan. The wheel would be the spinning blades. The axle is this metallic piece here that holds those blades in place, so it secures them together. Scroll back up to the top to keep reading about a wheel and axle. A water faucet has a wheel and axle on it. The knob you turn is the wheel. When you turn the knob, you are also turning an axle that it's attached to. A fan is another example of a wheel and axle. The fan blades, are the wheel, are attached to a rod, the axle. When the motor is turned on, the fan blades will spin and produce a nice cooling breeze on a hot day. All right, there's our background about our wheel and axle. Let's switch to focus on a pulley. Pull that pulley. A pulley starts with a wheel containing a groove running around it. We can see that right here in this photograph. This is the wheel, and if you look closely where the rope is, it's sitting between grooves that are holding that in place. Add an axle and put a rope or cable. Put them together and you have a pulley. When you work with a pulley, lifting becomes a cinch. Why? The rope on each side of the pulley supports half of the entire weight of the object being lifted. With one pulley, you only need to use half the force required to lift the object. Imagine raising a flag to the top of the pole without a pulley. How would you do it? You could take a ladder and climb to the top and fasten the flag. You could use a ramp and push it to the top. The easiest way would be to simply attach it to a pulley and hoist away. Letting pulleys do the job is safe, simple, and fun. All right. Back on your seesaw assignment, you will see on slide 3 links to Google image searches that have been set up for you. I want you to click through the images and discover one example of a pulley in our real life world, one example of a wheel and axle in our real life world, and write the names of these objects on this slide. I'm going to pop you into breakout rooms so you can discuss this together and see what you can find. And then we will come back together to share. Okay, to be sure, you now should have a written word or a typed text box right here that is telling me the name of one real life pulley and one real life wheel and axle that you found on that Google image search. Okay. All right. Let's hop to slide 4. On slide 4, you are taking a look at wheels and axles. We're going to watch this video and then we are going to record one thing that you learned about wheels and axles. Okay, so let's take a look. And as you're listening, think about one thing that you learned from this video. Come on, you can do it. There we go. And screen. Okay, is the sound? Yay.
Welcome to Fun Science Demos, and we're going to start today with a history lesson in honor of the Great Pyramids. We're going to build our own little pyramid. We're not going to use big, huge blocks of stone. We're going to use little bricks. Now keep in mind, when they built the Great Pyramids out of these huge, big blocks of stones, they didn't use complicated machines like cranes and bulldozers and dump trucks. So what did they use? Well, we're going to take a closer look at what they used. They didn't have complicated machines to move these big blocks of stone, but they did have simple machines, and those simple machines made their work easier. And that's the big idea. We're going to take a closer look at the wheel and axle. So let's start with a question. How much does this brick weigh? To figure that out, we're going to use our spring scale. So take a look at this. I'm going to lift the brick off the table and take a look at our spring scale. It's reading a little over 1,000 grams, or right at 1,000 grams. Now those big blocks of stones in the real Great Pyramids weighed a lot more. There's no way they could lift those blocks up and carry them. So let's see what happens if we try and drag this brick. If they could drag those big blocks of stone, and see how many grams it takes to move this brick if I drag it. So now let's try dragging our brick. I get it started moving, and I can look. It's between 300 and 400 grams as I drag the brick. So it was easier to drag this brick than it was to lift it up and carry it. But the blocks that made up the Great Pyramid were so big and so heavy that they were even really difficult to drag. So the people back in history had a problem. How do we move these massive, huge, big blocks of stone? Well, through science, we've discovered that you usually solve problems by asking the right questions. What if? What if I cut these trees down and use these round logs to go under the block? I wonder if that's going to make our work easier. So we've placed our block on top of these round tree logs, and now we're going to pull it and see if our work is easier. Let's try it out. So I gently pull. Believe it or not, my spring scale barely moved off of 0 grams. It hardly took any energy to move this block on these round tree logs. But what do we do now? We're out of tree logs. So that means we would have to pick up this tree log and move it to the front, pick up this tree log and move it to the front. pick up this tree log and keep moving the tree logs to the front from the back. Well, that's a lot of work too. Well, good news, science is not finished yet. Well, what if I take this tree log and cut sections off of the tree log? Let's see what we're left with when we do that. So what do we have? Well, we have the wheel. But how do I attach this wheel to our block? Well, through science, we've discovered that we can attach two wheels with an axle. This piece of wood is going to be our axle, but I need some way to attach the axle to the wheel. And to do that, I'm going to use styrofoam. Now, cutting styrofoam is really not a kid-friendly thing to do. It's difficult, and you don't want kids using sharp knives or cutters. So we came up with a really kid-friendly way to allow kids to cut styrofoam. It may not be the prettiest, but it works. So all I'm going to do is trace my wheel on my styrofoam and use something thin like this screwdriver and just go around the wheel, punching down the styrofoam, taking my time, working my way around the wheel. It's pretty easy to push through the styrofoam. And once I get all the
It's a terrible noise. I agree, Miss Bram.
way around, now all I need to do is push, and it comes right out. Now we need to take our styrofoam plug, put it into our wheel, and now I'm ready to attach my axle. Just going to push my axle into the styrofoam on both sides. And it looks like I have a wheelbase that's ready to roll. We also took a clear straw and put it through the wooden axle so our wheel and axle can spin quite easily. Now we have to attach this to our block, and we're going to use some tape to do that. One piece there, one piece here. Now let's see how our block rolls. May not be the prettiest thing, but I don't have to keep moving my tree logs in front of it. It always has some wheels attached, so now it rolls as I push it. Think about how far we've come since the age of the pyramids and how we use the wheel and axle today. Bicycles, skateboards, rollerblades, cars, airplanes, you name it. Everywhere we look, we can find the wheel and axle at work. And that wheel and axle makes moving things so much easier than if we had to drag them or lift them or carry them. Simple machines at work is a beautiful thing. It's so beautiful, I might just hop on this bike and have some fun rolling around. Science is so cool, especially when it helps make our work so much easier. If you want to learn more about simple machines or the wheel and axle, check out our links in the video description. Thanks for watching.
All right, so we've taken a look at our wheel and axle. I want you please to look at your seesaw assignment. What is one thing that you learned? Take a moment to type one thing that you learned about the wheel and axle here. Go ahead. So one thing that I learned is an axle has to be connected to a wheel in order to work together. You're going to go share with your breakout room what is one thing you learned about a wheel and axle. This is going to be a very quick share. It's going to be very quick.
We can't hear you.
Terrence, you can hear me. Other people can. You turn your sound up. This is going to be a very quick share, just about a minute, because it's just one sentence that you're reading, okay? What is one thing that you learned? And go. Okay. You are getting ready to go complete this section with your partners. You are going to read the text and use it to answer the questions on slide 9. Please remember that you and your partners can also choose to click on this audio text and listen to the text as well, if that's easier for you to do as partners. You're going to read slide 5, slide 6, slide 7, and slide 8, and answer the questions on slide 9. What is the main purpose of a wheel and axle? And where is the axle located in a wheel? Okay, remember, you're not using your background knowledge. You are using information from the text. You're not using your video knowledge. You are using information from the text. Okay, so what does the text tell you is the main purpose of a wheel and axle? What does the text tell you about where an axle is located? Any questions before I send you in to do your work? All right. I'm going to give you guys about 12 minutes to either read or listen to these slides together and talk about your answers. Remember, your answers should be in complete sentences. It's right there. Okay. Yes, Tim.
Are we going to be making the cars for the end of the year thing after we learn more about wheels and axles?
This is one of the pieces of knowledge you will need for your cars. That is correct. You guys will have a material pickup sometime next week to get all of the materials that you'll need for your cars, and then we'll begin construction. Okay?
Okay.
All righty. Okay, friends, here you go. All righty, friends. So you should have completed slide 9 with your partners. You are being graded on slide 9. So if you and your partners did not complete it, you need to make sure that you get that done independently. The rest of your task is repeating this process for Pulleys. You will watch the video. You will type one thing that you learned from the video. You will read slides 11 through 14. You will answer the questions on slide 15 in complete sentences using evidence from the text. On slide 16, please create a video. Notice what this says, explaining what you know about wheels and axles. Some of your videos have been telling me about your asking and answering questions. That's how we're doing it. That's not our main goal. Your main goal is science right now, so make sure your video is telling me about what you learned about wheels and axles.